Assalamualaikum warahmatullahi wabarakatuh. Okay, so inshallah this is last part of our stability method of analysis. So we now want to highlight on the non-linear method. Okay, non-linear method. If you could go to the slides. So actually I put a lot of general overview of slide method. Overview of the slices method. Okay. By using limit equilibrium, you can read there's a lot of method of slices assumptions, and it differs from one to others, such as here, if they use ordinary Fellenius, so first direction post equilibrium, yes they have, but in the second direction, some of the methods doesn't doesn't have the post equilibrium in the second direction, and some of them assume for the moment equilibrium, but some of them not considering of the moment equilibrium. So each of the methods actually have their own strength and why they do that. But you can see here, this is the slices that you need to do when you have a slides, when you have a failure plane. And one thing that you need to know, okay, when you have a circular failure plane like this and method of slides, the point that we assume where is the origin of the radius for the circular slips is very important. So that's why when you use software, so you have to do quite a few times to ensure that you get the best origin of the radius for the slip surface. And you also can see here two different types of soil, maybe with the groundwater table. But you can see the manners of the solution is much more easier when you use a table tabulate type of data. So we can simplify the process. We just noted what is the weight, length, alpha angle of the slices, cohesion, phi angle, for water pressure, and of course the forces that use. Because at the end we want to develop the equation of factor of safety, yeah, like you can see here, factor of safety, comparison between N1 and N2. Okay. So let me go quite fast. You can have a Bishop modified method, Fellenius. We can also have a computer aided limit equilibrium and so on. Okay, but for our courses, so here we will cover, I think Fellenius, Taylor also. So I skip all the slides. I just go straight forward for the one that we need to focus on. So let's see this slide, method of the slices. So let's say we have a circular slip like this one. So deep-seated, you can call this one as deep-seated. It is actually similar to previous concept. So we still need to know, okay, I hope you still realize, because let's say this is one slices that we want to start analyze with a certain width. So this is B, the width. Okay? So let me put out outside here. So we know that for the circuit, for one element from the slice, so it still have a weight. So weight of a I, so I slice. And here they have a forces and reaction force versus in the first side to the second side. And noted that at the bottom is it is a circular, so we can get the forces, normal force, okay, Ni and also Ti. So let's see more. Okay, the total weight of the slice can be defined by knowing the unit weight. So the unit weight usually in the kilometer meter cube. The width of the slice and also the height of the slice. Okay, usually for easiness, we sometimes divided the slice of the failure plane into a similar beam, similar width, so we can have a consistent width. But it's not limited to similar one. We can still have a different type of different sizes of the width. So effective normal forces N comes from the effective stress times the L, and the boundary water force for water pressure is for water pressure times the L, and shear force at the base is T, which is T that mobilize or induce the strength, induce the failure times the L. And total normal forces on the both sides is E1, E2, if you still remember. E1, E2. So X1, the shear force versus each other, X1. So this one should be X2. Alright. In order to make easier for us to solve the condition, solve the problems, some assumption must be made. Okay. So interslice means when we have a lot of slices between the slice to another slice. Sometimes we assume E here and E here is similar. Sometimes. So depends on the method that we choose. Okay. So for here, taking moment about the O. Okay. So when we have a circular slip here, so we take a moment. So this one, if we use software, we need to try and error, pick the correct radius in order to check for the correct factor of safety. But I could say that this comes with the experience. When we go to the site and we see the embankment height and also the type of the soil, we actually need to have some vast knowledge how big the failure might occur. So that's why we can assume the failure line and the radius correctly, and then pick the point of O correctly. Okay, so the sum of the moment of the shear force T, shear force X, at the failure AC must be equal to the moment of the weight of the soil mass. Okay, if we have T and weight, okay, it should be in the equilibrium. So TR equal to weight radius sine alpha. So what is sine alpha? So if we have a slices with a circular slit, so usually straight and sum of angle. So this is a alpha. I could say that this is tangent to the circular slit. So this is the alpha. The tangent to the circular slit angle is the alpha. So tau at failure times the L divided by the F is equal to weight sine alpha. So the factor of safety can be rearranged into this equation. So in terms of effective stress, all these tau F become C primes stress effective tangent P times the L width of the slice divided by the moment that induced. Or we can use in the these terms can also be used. So this is actually stress normal times the L, okay? Where the LA is the arc length of the AC. So this is another type of paralleliness. So for the paralleliness, we can use another derivation. So in paralleliness, they assume the resultant of the interslice is 0. Means that if you have slice that been analyzed side by side, so the first slice, first, second, and second slice doesn't have any E. So resultant of the interslice forces is 0. So that's why they directly use the effective normal stress equal to W cos alpha minus the hot water pressure times L width of the slice. So that's why the factor of safety in the effective stress they got this one. The equation is this one. And when the phi undrained is 0, so without any phi value here, so the factor of safety is simplified into this kind of equation. So let's see an example. Okay. Right, knowing the alpha here for a slice, we can also know the distance where the weight is reacted. So weight should be in the moment to the point of origin radius. So as long as we know the alpha, we can take as is r sine alpha. So we know the r. Okay, for example, we have a slope here, and we already divide them into slices. So we also know part of the soil having a groundwater table. So slice 1, the alpha is negative 18, alpha for slice 2 negative 7, alpha for 3 is 8. I will use this kind of here, 24, 8, negative 7 is just a matter of what we call direction, negative 18. And we also know the height. Also width also, and gamma. Okay. So knowing that, we can solve either using like this or put into table. So once we know, we put into table, we got the weight, alpha, C prime, PA, the width. So we solve for N1 and 2, we can get the factor of safety. Another example using paralleliness. So this one, the width is already set to 2 meters. And still, similarly, we have a groundwater table. And then first layer have these properties. Second layer of soil have these properties. So some of the slides using properties number 2. Most of the slides may be using properties number 1. So knowing the slice size, this is alpha. So this is the slice, first slice, second and third, and follows. So we put the value all into the table, alpha, beta, and so on. So we solve for the FOS. So FOS 1.1, barely stable. Okay, barely stable. We can also use modified Weierstrass because, but this is quite difficult because we have to make a balance between before the symbol and after the symbol. Okay, but noted here, L is B secant of alpha. So we got the FS. So it's quite difficult. So sometimes we need to use a computer program. Okay, so I think I stop here. You can read for the rest. So until we meet again in the live class. Assalamualaikum warahmatullahi wabarakatuh.